Hello, Bio4, and welcome to part 6 of respiratory, where we're moving on to the lungs. We start out by thinking about where they're found. They're in the thoracic cavity, and the walls of the actual cavity, of the pleural cavities, are covered with the parietal pleura. So remember, many times we have a coating that's the visceral and then the parietal coating. So the one that is actually going to line the inside of the chest cavity is the parietal pleura. And then on the lung itself will be the visceral pleura. So these organs are soft, spongy, cone-shaped, and we know that the right lung has 3 lobes, whereas the left lung is limited to only 2 because of the location of the heart. We think of the apex as being cranial and the base being caudal, which sort of makes more sense in my brain than the heart, which is sort of the other way around, because the larger section of the heart is the base, which is superior, but not here. So this might be a little tricky, that lungs are receiving deoxygenated blood. That we know, that's not tricky. What's tricky is to think that it comes from the pulmonary arteries. You're tempted to say pulmonary vein because it's venous blood that's arriving there because it's deoxygenated, but it's not. It's an artery because, by definition, a vessel leaving the heart, arriving at the lung, is going to be an artery. And then the drain is oxygenated blood via the pulmonary vein. So it all seems a little backwards when it's there, but that's the way it is. So if you need a reminder, if we're right side of the heart and pumping out towards the lungs, it's an artery. The fact that it's deoxygenated doesn't matter. It's called an artery. Okay, we got that straight. And this is just a better picture of the lobes. 3 lobes, you don't need to know all these elaborate names, and 2 lobes on the left. Okay, I'd like to move on to the pressures within the lung. This is very important because it's going to matter whether the lungs are inflated or not and how they stay inflated. And in order to do that, you have to think of gases. You have to think of oxygen moving along with its nitrogen. All atmospheric gas is moving in. But the only way that you can get a gas to move from region A to region B is to make region A higher pressure and then region B lower pressure, and it's going to travel in that direction. Also, another important thing about the pressure in the lung is that we want the lung to stay partially inflated even when you've exhaled. So we have 2 pressures within the lung. One of them is within the lung itself that we're going to call intrapulmonary pressure, right? Pulmon meaning lung. And the pressure in the pleural cavity that is going to be intrapleural pressure. So let's look at some diagrams. If you had a lung like this, you would have a visceral pleura and a parietal pleura. And that parietal, that space there is the intrapleural pressure. Okay, visceral, parietal, and the intrapleural pressure is in between. And then in here they're calling it intraalveolar pressure, we're calling it intrapulmonary pressure. So now I'm going to take you back to the previous slide, and I'm asking here, one of these is lower than the other, they're not equal. One of these is lower, and which do you think is the lower one of the 2? So the trick here is that we need to keep this lung inflated. When you're exhaling, it doesn't mean that your lung ends up like that. It doesn't. It's still attached on to your thorax here, and it'll have lower pressure in it or higher pressure in it, but we need it to stay attached. So then we know that the negative pressure, the lower of the 2 pressures, needs to be in this region here between the 2 pleura so that it drags it out in that direction and prevents it from looking like a collapsed lung. Okay, so intrapleural pressure is lower. it's written out for you. Intrapleural pressure is always slightly lower than the intrapulmonary pressure, and this is going to allow the lungs to kind of stick to the thoracic cage and move along with it. This is an example of it not functioning, of a collapsed lung, where we did away with that difference in pressure. So if you do away with that tiny little bit of pressure here, then this lung would retract and it would look like this. And we don't want that to happen. You can be exhaling and it will still look like this. The next section is on the actual mechanics of breathing and how it is that pressures are going to change in order for you to get air into the lung and air out of the lung. So I'm going to leave that for the next mini lecture. Thanks. Bye, guys.